Hello and welcome to Maths with Mr Amison. Today I'm going to be talking about how to find missing sides using Pythagoras theorem. If you haven't gone over Pythagoras theorem in a while, then it would be worth recapping using the link in the video here or in the video description below. This video is all about practicing how to use that theorem to find missing sides. So, to get started, let's go through a couple of examples and then I'm going to let you have a turn. So here we have two right-angled triangles, as you can see. And what I'm going to do, I'm going to show you the working out for this first one and then I'll talk you through it afterwards. So as the working out appears on the screen, I like to think about where each line comes from and think about how it might apply, and then I'll go through the working out and why I've done what I've done. Okay, if you still want a couple of seconds to have a think about it, please pause now. So, this first line comes from the fact that this here is Pythagoras theorem. Because we have a right angled triangle and we're trying to find out this side length, and we have two side lengths given to us, we can use Pythagoras theorem to find out the third side. Now it's worth noting that this third side is the longest side in our right angled triangle. That's because the longest side is always opposite the right angle. It's also worth noting that the letters A, B and C, which denote the corners or the vertices, as they are rightly known, are capital. In Pythagoras theorem, the A, B and C are all lowercase. Now, capital letters are representative of the corners, the vertices, and lowercase letters are referring to side lengths. So, in Pythagoras theorem, the side lengths A and B are the shorter sides, and the side length C is the longer side, the hypotenuse opposite the right angle. So, A and B are 3 and 4. It doesn't matter which order they're in, because A and B could be either way around. 2 squared plus 3 squared is the same as 3 squared plus 2 squared, for example. So I can replace A and B with 3 and 4. It doesn't matter which one. So C squared is therefore equal to 9 plus 16. C squared is 25. 9 plus 16 is 25. And C is equal to 5. Now it's worth noting that C squared equals 25. C could equal plus or minus 5 in answer to this. Now in this case, C can't equal minus 5 because BC is a length and therefore it can't be negative. So in this case we can only have the answer C equals 25, C equals 5, not the answer C equals minus 5. Let's go through this one. Okay, pause now if you wish to spend a few more moments thinking about this. So it's worth noting again that we're using Pythagoras theorem because we have a right angled triangle and we're given two lengths, we're finding a third length. And the longer side, opposite our right angle, again, is in the same place, in this shape. And our longer side is given this time. Our longer side is 4, so C has to be 4. And then one of the shorter sides is 3. So you can replace A or B with 3. It really doesn't matter which one. So we end up with 4 squared equals 3 squared plus B squared. So 16 equals 9 plus B squared. 7 equals B squared. Rearranging this by taking 9 away from both sides of our equal sign to keep the same amount on either side of our equal sign. So we end up with 7 equals B squared, which I can write as B squared equals 7. Now you should remember, to get B from this we can't divide by 2, we have to square root both sides of our equal sign to get B equals the square root of 7. Now that's not a nice number. If you type it into your calculator, you get a big long decimal, which you can write to three significant figures as 2.65. Alright, so your turn. Have a go at these two questions. You can pause now and have a go. Alright, so what we should have got was, we're using Pythagoras theorem again. So c squared is 10 squared plus 24 squared, because 10 and 24 are the shorter sides. So c squared is 100 plus 576. C squared is 676. And c equals, therefore, the square root of 676. So c equals 26. Now if you look at the next question, what's similar and what's different? Well, this side here is now supposed to be our longest side, which if you look at the question doesn't make sense. The triangle is rotated around, so the right angle is now over here. And opposite that right angle should be our longest side, but we've got 10 and 24 as a shorter side. I'm going to show you why that doesn't make sense. If I replace my c with 10, then I get 100 equals 576 plus b squared. If I then take 576 away from both sides, I get minus 476 equals b squared. Now that's impossible, because if you square any number, you should always end up with a positive answer. For example, minus 2 squared is 4, but also 2 squared is 4. Remember, if you do that on a calculator, to put brackets around your minus 2 before you put the squared, otherwise it will give you minus 4 and it's not right. So, a square number always has to be positive, therefore this is impossible. Well, it shows in quite a nice way that side length opposite the right angle has to be the longer side. So here are 6 questions for you to try. Questions 1 through 4 are quite standard questions. As you go through them, I'd like to think about what's the same and what's different as you go from one question to the next. Try and use the previous question to help justify why you think the answer that you come to is correct, or why you think it might not be correct. Question 5 and 6 get a little trickier. Question 6 in particular is rather difficult. So pause now and have a go. Okay. So the answers are on the screen. I'm not going to go through questions 1 through 4. It's worth noting that this one we're finding the longer side. This one is exactly the same triangle as question 1, we're just finding the shorter side. Question 3, we are again finding the shorter side, but instead I've gone to using decimals. And then question 4, the 5.5 is the same, but instead of giving you a longer side, I've given you a shorter side that's missing, but it's a different triangle this time from question 3, and we get x is equal to 14.3. Question 5, we have a third, and that's what makes this a bit trickier. It's worth noting that if we do the square root of 11 squared, we get 11. 5 squared, we get 25. So x squared is those two added together, which is 36, which means x has to be 6. Question 6 really is quite tricky, noting that 2x squared, this long side here, is equal to x squared plus 3 squared. So 4x squared in total, remembering to put your 2x in brackets, but we're replacing c with 2x. So the whole of 2x has to be squared. So we end up with 3x squared when we subtract x squared from both sides is equal to 9. We can divide by 3 to get x squared equals 3, and then square root that to get x equals 1.73 to 3 significant figures. Thanks for watching. Now you've had a go at this, why not have a go at trying to find missing sides where there's more than one triangle piled up on top of each other. It's a good next step for you to try. Speak to you soon.